This is the MatrixMadeEZ project. In this project, I have attempted to recreate the game Flappy Bird. In Flappy Bird, there's a bird that flies through incoming walls. If the bird hits a wall, it is game over. The dot on the left represents the bird, and the moving lines represent the walls. The flapping of the dot is controlled by a PBNO. Every time the button is pressed, the height will be increased by 2. Every time interval, the bird will fall 1 space. Every 2 time intervals, the walls will shift over 1. To check to see if the player hits a wall, the code compares the player's location to the wall's location. If the player and the wall have the same location, it runs the game over function. The player scores every time they pass a wall. To check if the player has passed a wall, the code looks at the column of the bird. If there are no walls in that column, the spaces around the bird will be 0. Since the bird starts in the 5th column, the 5th column will be 2 to the power of 5, or 32. If there are walls around the bird, they will be equal to 32. To keep the code as efficient as possible, there are 2 parts to the interrupt function. One will only run if it is game over, and the other will only run if it isn't a game over. This project uses the 74HC595, the TPIC6C595, and an 8x8 LED matrix. The 74HC is a shift register and will store an 8-bit input and output that input to the anode pins of the LED matrix. The TPIC is also a shift register, but its outputs are drains. The TPIC is very useful as it helps maintain a constant current. To function, the ATmega will send 2 bytes of data to the data pin. The 74HC will take 1 byte and the TPIC will take the other. To prevent the wrong LEDs from lighting up, you must use a persistence of vision effect.